For the clusters.
Okay, everybody. So this SI session, we're gonna work in clusters. First off, I want you guys to go into groups, however you like to arrange your groups, and answer each of these questions. Okay, so get in your groups, please. Okay. I want you guys to do number. Which one do you guys want to do?
What do you want?
Okay, you guys do number 1, and you guys do number 2. I'm going to be joining you guys. Just
Okay.
help you out and be a student.
A volume and a density. No, I said a volume and a density.
Oh.
We're finding mass.
So what's the equation for density?
Density equals mass of a volume, right? And so then we're solving for mass. So density was 1. So it's just 2 kilograms per millimeter.
Kind of. How about we listen now?
So is that 6 grams?
So you guys remember, what was the
Oh,
kilo to the
sig
base?
figs. My bad.
Yeah, sure.
And then what was
Sig figs.
was deci, right? Centi. And then these are the 2 that we want.
Right.
This is 10 to the 0, and we go up 3 every time. So this is
26.
you guys want to fill out the rest?
Yes.
So this one would be
Now you're just getting
10 to
I
the,
know.
remember these go by 1s. So 10 to the 1. Like that? Negative.
So number G.
Oh, 0, -1,
Now
yeah.
you just do this one. We're just doing 1, right? What are the
Yep.
questions?
We'll just go over. You guys are done?
Yeah.
I'll start over here.
It's gonna be 5 kilometers.
Do you mind if we help this?
Yeah, actually, yeah. That'll be awesome.
Kilometers.
One.
Okay, 1 way. No, just go to meters.
Oh, no, we're going to millimeters.
Go to meters and then millimeters. Faster. Not faster, but you don't mess up your math.
You want to set it up to cancel, right? Wouldn't that be
Yeah.
what the professor said?
Yeah, because we,
Kilometers on the bottom.
like this, right?
Mm-hmm.
Yep.
So 1 kilometer is equal to 10 to the 3rd.
Yes.
The one with the prefix.
maybe 3.
No.
It's just the third.
3rd. There you go.
Oh, because we're, yeah.
So
Exactly
meter.
as you should. Very good.
3.
Oh,
You
third.
use 3. Because 1
Twenty,
kilometer.
yeah.
There you go.
Right. Kilometers are big.
What's next? Now that you have kilometers.
Then we want to cancel out meters.
So
And we want millimeters on top.
negative 3. There you
Uh-huh.
go. Millimeters.
Millimeters.
Now the setup looks okay, but wasn't it? Which one has the prefix? The prefix always gets the 1, right? So what would this one be?
That's right. Yeah. 10 to negative 3. Now,
Which one has the prefix? This one, right?
Yeah.
So this guy gets the 1, right? Yep. Okay. And the other one will get what? If you remember what it was. Millimeters is 10 to the what?
Negative 3.
Yeah. Okay. So we got this guy cancel. This guy cancel.
Okay.
Then our answer.
Cancel out.
So you know what it is?
No.
5.0. What happens when you multiply exponents?
Well, hold on. This is gonna be,
Times 10 to the what?
Yeah, there you go.
Excellent. You should repeat the times.
They're additive when they're divided?
yeah. It's because this one is to the negative.
It's a negative, so
When
it
you
goes
move it
up
to the
to the
top, it becomes positive.
Oh.
Very good. Okay.
The review.
How about this one? You guys understand that one?
Hey, we were right.
So density equals mass over volume. We solve for mass because that's what you're looking for. And then plug it in.
Yeah, very much.
Makes sense.
Make sure the units cancel out. If this is on the numerator, milliliter, and this is on the denominator, what happens?
Cancel.
They cancel,
And
yeah.
you just get grams.
And then you get grams as your unit.
Yeah.
Excellent.
And it makes sense because it has to be mass, no?
Yes,
Yeah.
very good.
Yeah.
Excellent. All right, very good, guys. All right.
Yay.
Now in this group, who was or who were the SI leaders? Okay, one resident. Comments?
They were all
they were all working together. And I didn't really, I saw them kind of maybe helping a bit, but it was mostly them. And then I heard, I think it was Steve say, "Can I help?" And then he said, "Yeah, get in there, good idea." So he was mostly letting them do it.
Anyone else?
Is there anything you guys think I could improve on? Maybe?
Yeah, anyone see the opposite? Anyone see something different?
Don't be such a nice guy.
Alright.
Be mean.
I've never seen a little difficult to kind of reenact it, like having them redirect them to like do it themselves, because they don't exactly have papers or their notes of what to go, where Ben to go, oh, you know, why don't you look at your notes to go through or something. So he did the best with as far as like redirecting, so like letting Steve remember what was in it and then just trying for them.
Did you notice if he used any of these questions?
Yeah, so where he did, well, he just let.
And I'm not just asking
Oh,
Francine.
okay.
Thank you, Francine. You're wonderful. Everybody else, did he use any of those questions? Did you see that?
I think like wait for like, are you sure? Like, I don't think
Okay.
That's what I was looking for.
Why the are you sure?
because when they acted out, they seemed like they already knew everything. So like, are you sure this is right? I don't know.
Well, it's kind of hard because they haven't actually had any of the classroom experience for chemistry. Like for,
But that's the idea, right? We don't have experiences. Like we go to the class and we have no clue what we're doing, right? We do. I mean, that's really who we are, right? When we go to a class and I have no clue what I'm doing. So,
But in that instance, so like if they don't know it and they like he has them to redirect each other and they don't know it.
so then what?
I would show them how like a similar problem the first time and then like have another.
Do they have notes? Do they have notes on it?
Yeah, the problem is that we don't have notes.
Yeah, we
Right.
didn't have notes.
But that's the idea.
Right.
Okay.
You'd have them go back to their notes and figure it out. And keep working on
Do
it.
they have the textbook when they come to you?
I tell them to. I tell them to bring all their stuff, but you know.
Do you guys have the textbook?
Put it on the
I
flyer
bring-
that I made for them. I put on their kind of basic rules. One of them said, bring your notes and your textbook.
So, little preparation. So, any other questions that you think that are helpful from this? Are you sure gets used a lot? Any other things that you don't, that are embracing something positive, yet you're asking a question? Do you see that? Which question? From here? There's something, a positive question, but it's asking for more on the part of the student.
How did you do that? So that helps them like narrow their steps or
What are we trying to find out? So you have to, you're forcing them to explain to you why. Why are you doing this?
The problem. Figure out what they're looking for.
Or show or ask them to explain what they did to the other group.
So notice that there's even one here that says, let's rephrase it on the board and figure out information we will need to answer. Like there's things that you can address in a positive way. They'll see it as a positive way. So it's not the whole, because we got into the credibility idea. Like, so what do you think? Like, you can end up in this rot. So what do you think? So what do you think? And then they're like, well, what do you think? Like,
Yeah.
it's the back and forth that they're expecting. Well, I don't care. What do you think? And so it's changing the wording that matters. You're asking them the same thing. It's just in a different kind of wording. And this takes practice, by the way. So sometimes like really reading through and memorizing some.
Bring
That's
it
a
with
start.
you.
It's really a start. Memorize some of them that are like not too common, so that so that they're really thinking, oh, this person is really inquiring what I'm trying to do.
you have your outline and you're using that to reference the flow of your session, put those on there and highlight it to trigger like, oh, that's a good question, I can ask it.
Sometimes asking the right question helps them remember something. Ask in a different way, they're like, oh, I get. Yeah.
I do that in my sessions, like, what's the warm-up?
What do you mean?
I'll put like some questions, like, to just define certain formulas they need to know, or certain like right now we're doing slope intercept, so like N and B, like what they represent, and the different ways you could find slope, just by either looking at the equation, and have them answer the questions and explain how they look to look for.
So I'll tell you, I gotta claim something I do as a teacher, and I hate doing it, but it's just my brain goes to it. And I always ask, do you know what this means? Right? And I like highlight the word, right? And then everybody goes, yeah. And I don't ask it, it's not asked in the right way. Can you represent this word in different, like some sort of like different way of asking it? Can we draw a picture representing this word? Sometimes that's very good. And so that way really makes people think, how do I think of that word?
It personalizes it for them, correct?
Right. It's not like, well, do you know what this is? And everybody's going to say no or yes, and that's it. I mean, that's all you get out of it. Yeah. Dan?
Yeah, because sometimes when I give them a problem, and we're done with it, we're like, go through the process and I ask them, do you understand? And sometimes they give me yes, someone tell me no, but like, because some of them are too embarrassed to like say they don't understand it.
So what question can you replace that with? There's some questions that I know that we can replace. Like,
how did you do that?
How did you do that? Beautiful. Any other things?
So instead of asking if they do they understand, I ask them how did they do that?
Yeah. And we teachers do that a lot.
Can you be more specific?
Can you be more specific? Yeah. How would you do that specifically? Or how would you say that in a different way?
When you're doing math, it's a constant questioning yourself at each step. Okay, what's next? Am I going to use the multiplicative property of equality? Them knowing what properties that they're going to use as far as the steps. They're going to solve a two-step equation. They need to know that most of the time the first step that they're going to do is by addition, and then the second step they're going to do is by multiplication and division. They need to be able to ask themselves, what's my step? What's my purpose for this problem? And if they hear you asking those questions, one of the things you could say in your session is, maybe you should write down some of the questions that I'm asking at the steps that you could ask yourself when you're at home doing your homework, and it might help guide you.
So I'm going to leave you with a note, and that is kind of an example, and this goes to my students as well. Notice what the behaviors of your teachers are. What they say a lot in terms of how you know that that's breaking a cycle. Once you learn to recognize how they're not doing it, then you can recognize it on yourself as well, right? Don't call me out on it, I know I have to love you guys. It's gonna point. Yeah. But remember, as teachers, we haven't been trained to be teachers. We're just the same way that you guys are. So, do you understand? Do you understand what this means? Okay, cool. And it's a yes or no answer, and then we see, okay, well, they didn't answer. Okay, well, we'll move on. And so it ends up in that whole, avoiding the rest. So if you can identify what your instructors do, when you're like sitting there in the lecture, where's the breaking the cycle part? Like, and then that way you can recognize it and you avoid it. The more you learn by recognizing something else. Thank you guys. I appreciate your time. And yeah.